Hello guys! Hello BSRT3 students! Welcome back to our virtual classroom, to our e-learning portal of the University of Eastern Philippines. Good morning ladies and gentlemen. Welcome back to our subject. This is RT315 Radiation Protection. So this morning we are going to discuss artificial radiation sources. But before that, let us first have a short recap of our previous discussion that will start in 5, 4, 3, 2, and 1. So as you can see in the right side of your screen, we have our discussion the last week. So we discussed about the natural radiation sources. And so we described the three different sources of natural radiation. That includes, of course, first we have the cosmic rays. We also mentioned of the cosmogenic radiation and the primordial radiation. So, under cosmic radiation, so we stated clearly that cosmic radiation includes both primary extraterrestrial radiation that strikes the Earth's atmosphere and secondary radiations produced by the interaction of primary cosmic rays with the atmosphere. And so, we clarified that cosmic radiation are radiation emitted by the heavenly bodies such as the stars and the sun. And of course, along with that, we mentioned that air travel can substantially add to an individual's cosmic X-ray exposure. Okay, so significantly, among these, air travel is from the supersonic high-altitude aircraft such as the British Concorde. So also we mentioned of the cosmogenic radiation. Again, these are secondary cosmic radiation plus the atmospheric radionuclides. So their interaction produces cosmogenic radionuclides. And the primary source of cosmogenic radiation is of course the carbon-14. Along with that, we also mentioned of the primordial radiation or primordial or the terrestrial radiation, and that we said that these are types of radiation that were produced since the existence of the Earth. So their half-life is comparable to the age of the Earth, which is equivalent to 4.5 billion years. And we mentioned different sources of primordial radiation. And the primary source is of course the radon-222. Second, we have the potassium-40, which is part of our human metabolism. Along with that, we also mentioned the different enhanced natural radiation sources. Enhanced because, again, they are natural radiation sources, plus there is a human intervention. So this includes tobacco smoking. Another, we have the water supply. Of course, that includes the potassium-40 and the radon gas. Building materials. And of course, other sources of radiation. And we also identified the different radionuclides that are present in the human body, such as the uranium, thorium, potassium-40, radium, carbon-14, tritium, and polonium. So guys, this morning we are to discuss the artificial radiation sources. This is just a short discussion, and I hope you listen carefully and get something out of our discussion for this morning. Okay, so let me start by reading the introduction. So diagnostic X-rays constitute the largest man-made source of ionizing radiation. This estimate was made in 2006 by the National Council on Radiation Protection and Measurements. So the fast-changing technological ventures offered in our society today largely contributed to the increase of risk estimates of radiation exposure. We are also exposed to sources of radiation created by humans. Aside from those natural radiation sources, we have man-made ionizing radiation. This includes sources such as medical and dental X-rays, nuclear testing fallout, and radiation associated with nuclear power plants. So let us discuss these artificial radiation sources one by one. And that will start with the medical ionizing radiation. So we said that diagnostic X-rays constitute the largest source of ionizing radiation. The benefits derived from the application of these X-rays in medical are indisputable. However, such applications must be made with prudence and with care taken to reduce unnecessary exposure of patients and personnel. That is why you are here in our subject. This is radiation protection, because along with the diagnostic procedures, our main objectives is to carry out radiologic procedures with care, of course, that will incorporate radiation protection not only to us radiation workers but also to our client. Of course, I'm referring to our patients. So, the medical use of radiation produces an annual average effective dose equivalent of 540 sievert, or that is equivalent to 54 millirem, which again represents more than 95% of the total artificial radiation sources and 88 of all technology-based radiation sources. That includes smoking. Okay, so again, it says here that 95% of the total artificial ionizing radiation sources, no? And that is 88% of technology-based radiation sources. So, we can say, of course, that the main component, if we can picture out using a pie graph, okay, we can say that diagnostic X-ray or the medical X-ray is the largest component of man-made ionizing radiation. There are only 5% remaining for the other radiation sources. Okay, because X-ray, CT scan, we can say also MRI, they classified as medical ionizing radiation. Anything that are used as part of the management of the patient, especially on the diagnosis side, so they are categorized as medical ionizing radiation. So there have been significant changes in medical imaging technology and its uses since data were collected. Though the dose per image from radiographic procedures have substantially decreased. However, the doses from fluoroscopy and computed tomography has increased since that time. Because, okay, so let's say, let's take for example from radiographic procedure. Because considering that analog, or what can we say, these because today we are now on the digital side, di ba? We are using, most of our hospitals are now using computed radiography or digital radiography. So based on our discussion in digital technology, we said that there is now the dose creep versus the technique creep. Okay, so that is why there have been significant changes in the medical imaging technology and its uses since the data was collected the last time, so that was in 2000 and 2006. Tama ba? So the dose, again, however, in fluoro and CT scan, because most of our procedures nowadays are CT and fluoro guided, that is why we can say that the doses from fluoro and CT has increased significantly. Okay? Okay. Next, we have radiation or radioactive fallout. So if you can still remember, we have defined radioactive fallout as the deposition on the surface of the earth of radioactive particles. So they are kept on the ground. However, they are released into the atmosphere. Kaya sinasabi nating fallout as a result of nuclear explosions and by discharge from nuclear power and atomic installations. So the disaster that happened in Beirut last August this year is not categorized as radioactive fallout because that was ammonium nitrate, probably, that was kept at the port, no? So they were not raised from the ground as part of nuclear explosions. So we cannot say that the Beirut explosion last August, probably that was August 6, 2020, is not part of radioactive fallout. So one of the main examples that I can give you for radioactive fallout is, of course, that happened in Hiroshima and Nagasaki in Japan. The little boy explosion, di ba? If you can still remember in our radiobiology. Okay, so let's go back to our discussion. Fallout from atmospheric testing of nuclear weapons. That includes 450 detonations between 1945 and 1980. Consists of large quantities of carbon-14. Okay, carbon-14 is the main component of radioactive fallout. That is 70% of the total fallout. And along with that, the 30% remaining chemicals or radionuclides are or includes tritium, manganese 54, cesium 136 and cesium 137, barium 140, cerium 144, plutonium and transplutonium elements. So before we just identified or we just defined radioactive fallout. However, this morning, so we already identified the different components of radioactive fallout. Again, they are primarily used as part of nuclear warfare. Kaya we can say that there have been 450 detonations between 1945 and 1980 because the modernized agreement of the UNSEER is already have been established, meaning there should be an agreement between two or countries before they will use this radioactive fallout because this is very harmful. This will not only affect one country, probably it will affect generation from to generation. So a large fraction of these radionuclides have since decayed or have become progressively less available for biologic uptake. So today, the dose from fallout is minimal and primarily due to, again, this is the main component of fallout, this is carbon-14, which together with other fallout radionuclides, as mentioned earlier, results in an annual average effective dose equivalent of less than 10 microsievert or that is less than 1 millirem. Buti na lang kasi there is now an agreement between countries, especially if they will use this radioactive fallout. Applicable ba yun? I don't think so between other countries like Syria and other kasi yung iba patago na, di ba? So di na na-detect masyado. But however, siguro or a moral lesson that happened in Hiroshima and Nagasaki, medyo nagiging aware na ang mga tao or ang mga countries, especially those that are in disputes, with the careful use of radioactive fallout. Okay. Next. Okay, so this discussion includes the nuclear power plants and industrial applications that contribute very little to our radiation dose. So the total contribution to the annual effective dose equivalent from activities related to nuclear power production known as nuclear fuel cycle is minimal, that is less than 0.5 microsievert or that is less than 0.05 millirem. Okay, so if you can still remember, Otronko, there are 95% of man-made ionizing radiation that are brought by the medical ionizing radiation. And 5% of them are part of these fallout plus the nuclear power plants. So, sa medical ionizing radiation, siguro there are no questions naman what composes or what are the radioactive substances because primarily X-rays, diba? And sa fallout naman, we have enumerated different sources and of course, primarily is brought by the carbon-14. So how about these nuclear power plants? Ano-ano yung mga radionuclides na nandoon sa nuclear power plants and industrial sources? Okay. So population radiation exposure from nuclear power production occurs during all phases of fuel cycle, including mining and manufacturing of uranium fuel, reactor operations, and radioactive waste disposal. Although many radionuclides are produced during the nuclear fuel cycle, carbon-14 is also the most significant contributor to population effective dose equivalent. Purbida ni carbon-14, kala natin noon, di ba we have said that carbon-14 is a naturally occurring radioactive substance, di ba? So actually they have been usa siya sa mga cosmogenic radiation, and now na-appear pala din siya. Kaya we can also say that it is also part of enhanced natural radiation sources. Kasi natural siya in a way, carbon-14, pero there are man-made interventions. Una, of course, is the radioactive fallout. Plus, now, we already identified that carbon-14 is also used as part or radioactive source in the nuclear power plants and industrial sources. Okay. So now let's come to other artificial radiation sources. Kasi yung iba dyan, takot gumamit ng cellphone. Ighatag na lat iyo cellphone na akon. Okay. Ano pa? May mga nare-receive kita na mga scam, na mga text messages, nga ganon, especially about gadgets. Sige nga, let us now have a clarification on these issues. Bangin makareceive pa ka mo, mahadlok na naman ka mo, Okay, now, modern technology has increased population radiation exposure. Technology-based population exposure to radiation sources can be categorized as enhanced natural sources, in which technologic enhancements to naturally occurring radiation sources have resulted in higher population exposures than would have occurred if left in their natural state. Pero kanina, mga na-mention natin, okay, so natural and source of radiation, carbon-14, so they are part of the letter A. Now we have letter B, technologically produced artificial or man-made radiation sources. Of course, this is with the exception of smoking. These sources represent less than 1/4 or 700 sievert per year or 70 millirem per year of the dose from the natural background. Okay, so let us identify this modern technology. Okay, technologically produced artificial man-made radiation bang hindi nagamit ini naton. Actually, before, in our subject that is radiation production and characteristics, we identified other consumer products that are part of man-made ionizing radiation, di ba? So we have identified the watch dials, especially the Timex Indiglo, exit signs, smoke detectors, okay, camping lantern mantles, airport surveillance system. That is, or a total of these consumer products contribute 0.1 millisievert to our annual dose. Okay? So, as you can see in our diagram, this is an illustration. If you still remember, this is an illustration of the, what do you call again? Very good. This is the electromagnetic spectrum. And if you still remember, there are three important parameters of the electromagnetic spectrum. Nano adto? Very good. So we have frequency, energy, and of course, the wavelength. Okay, sige. Ade. Important parameters of the electromagnetic spectrum to identify devices as ionizing or non-ionizing radiation depends on energy, frequency, and wavelength. So non-ionizing radiation does not carry enough energy to remove electron from atom or molecule. This includes electric power lines, wireless communication such as cell phones, cell sites, both mobile phone and base stations, Wi-Fi, radar facilities, TV and radio transmitters, MRI machines, ultrasound machines, laser sources, ultraviolet, and infrared lamps. So, hindi pala dapat na tayo matakot sa mga cellphones, laptops, and everything. Balikan natin si electromagnetic spectrum. If you can see, there are two divisions of this electromagnetic spectrum, non-ionizing and the ionizing radiation. So the higher the frequency and the energy, of course, we can categorize them as ionizing radiation. Of course, they have shorter wavelengths compared with the non-ionizing radiation. So our examples or yung mga nabasa natin kanina, they are categorized under non-ionizing radiation. Although we can say they are non-ionizing radiation, so here is our advice. We cannot go away with technology. But the bottom line is, moderation of their uses must be exercised. As promised, this is just a short discussion, and of course, that ends our discussion for today. So, here are my references. If you have time, I know you have a lot of time, so don't forget to scan your notes and to read your books. So, next week, we are going to discuss radiological units and quantities. And of course, do not forget to answer the quiz that is posted in this UEP e-learning portal. That is expected to be submitted this week. And if you have questions, so here are the different platforms to ask your question. First, you can ask me, of course, through our UEP e-learning portal in your Moodle. So you may comment your question or you may ask me personally. Second, you can ask me through our group chat in the Facebook Messenger. Okay, so you can ask me question and I can ask you question, di ba, para fair? And then of course you may comment your question in this YouTube video. And for the asynchronous learning or for the offline students via municipality link, you may ask your question through my personal phone number. Okay, so that ends our discussion for today. So see you next week and bye-bye!